Stephen will be talking about next generation mobility and if standardization is a help or a hindrance. Before he gets started, a little bit on his background. Stephen is now Vice President at UL, Underwriters Laboratories, with worldwide responsibility for UL's wireless, interoperability, security, EMC, and product safety businesses, with a focus on high-tech consumer products. After studying engineering science at Oxford University, Stephen worked for a number of years in the electronics industry before becoming the co-founder of RFI, an electronics consultancy and testing business. He grew this business over a 20-year period before selling to UL in 2010. Stephen has a particular interest in the application of mobile communications with a focus on the convergence of wireless and payments technologies, and on machine-to-machine communications. All of these very relevant to this event. So with that, I'd like to welcome Stephen up to the podium, and following his presentation, there'll be some time for questions and a nice exchange. So again, I hope you enjoy the rest of the conference, and welcome Stephen.
Thank you, Kevin. Good morning, everybody. So you can hear from my accent, I'm not exactly from these parts. I'm not normally quite this husky, but unfortunately I picked up a bit of a cold on the airplane. So I hope my voice holds out, and I hope you can all hear me in the far reaches of the room. So thank you, Kevin. It sounds quite scary, that introduction. It's actually not quite as scary as that. Anyway, last week I was in China and reading some previews for CES, and I was reminded of the song, "May you live in interesting times." As this is an IEEE sponsored conference, I'm fairly confident that my audience is both intelligent and educated. So I'm sure that you know the saying is sometimes known as the Chinese curse. And it's intended to be both a positive and negative, something that I will come back to in a moment. So, what makes this interesting times? Let's look at some of the headlines and takeaways from CES 2014, with a particular focus on next generation mobility. So, some headlines from the first of all from the CES website. A record 9 major car manufacturers are exhibiting their vehicles at CES this year. From USA Today, just to make sure we get a wide range of newspapers, consumer drones set to invade CES 2014. And incidentally, I'm not sure exactly what the organisers of this conference intended when they came up with the theme of next generation mobility. But 9 major car manufacturers and a flock of drones certainly puts a different perspective on it. Especially an exhibition which is traditionally associated with less mobile devices, PCs, etc. Another headline is time from the Wall Street Journal. Wearable gadgets put on a show in Las Vegas. Referring here to products which we talked about earlier from companies as diverse as Samsung and Pebble, Sony and Mimo, Qualcomm and Arcus, and many others. And from the Financial Times, Intel, I particularly like this one, Intel throws its weight behind innovative products and the Internet of Things. Well, I must admit, I thought that Intel had always put their weight behind innovative products. It's interesting to know that they're doing it now. And I suspect that Intel's PR manager winced after seeing that headline. Though of course it is actually referring to wearable electronics and a desire by Intel to get a larger share of the mobile chip market, which is dominated by ARM and Qualcomm. Then from Forbes, China tech makes the splash at CES in Vegas, prompted by a combination of a number of new Android phones from Chinese companies and a very substantial Hisense booth and other major manufacturers. So, one of the key things behind this innovation, I'm sure you'll all have your own favourite moments and products from the show. However, what these and many other innovations share is a drive by technology suppliers to commoditize the underlying technology and thereby allow a much wider range of applications and end products. Of course, this commoditization relies on standardization, even if that standardization is driven by just one company, as is the case, for example, with Android and with some of the other products we'll look at. So, one of the other themes of the technical journalists looking at the show has been the disruptive nature of many of the technologies, and indeed the disruptive nature of some of the companies behind them. I think anything that includes the word disruptive is immediately a warning signal for standards writers. Standards tend to dislike and avoid disruptive things. So I think it's worth looking at some of the disruptive forces that relate to next generation mobility. So one of the main features of this year's CES was the Internet of Things, which has finally gone mainstream. Incidentally, I'm not exactly sure when M2M, or machine to machine, morphed into the Internet of Things, but it certainly has more resonance with the average consumer. I think we're seeing the standardization of core hardware, chipsets, modules, etc., and the software to go with it. And that's driven down the cost of mobile internet devices. And as one would expect, this trend is continuing with announcements last week, including from Qualcomm. We have the new Snapdragon 802 video on a chip solution, and the equivalent products for in-car infotainment. From Intel, processors directed at competing directly with ARM, and a range of new sensors, including features such as 3D depth sensing. So actually your video sensor can now do probably more than your eye can. And a number of other major announcements. So as a result, we're now seeing the internet, and in particular, the mobile internet in devices just would not have been possible before. And I saw a nice example in a newspaper last week, USA Today, under the heading, Dog Days of the Wearable Tech, with a picture of a very sweet-looking retriever, golden retriever, holding a device in his mouth. This was discussing the use of the internet to assist in the long-term monitoring of your pet's health. This is something you never knew you needed, I'm sure. Whilst pet tracking devices have been around for some time, we are now, believe it or not, entering a new era of health management for pets. And just in case you're wondering why, it seems this is particularly useful for dogs, as apparently they are programmed to not display symptoms until relatively late in the progress of the disease. Well, you live in there. We're also seeing the Internet of Things appearing in more domestic or home appliances, ranging from refrigerators to slow cookers. And importantly, we are now getting much more usable and useful software, by which I mean apps to go with them. Very important to make these things usable to the average consumer. Looking then at digital health, the Internet of Things also encompasses applications which are not traditionally associated with CES, some of which have life-affecting implications. Increased use of the internet in medical applications is one example. And in case you're wondering, I am actually thinking beyond health monitoring of dogs at this point. Vital though health monitoring of dogs might be. Whilst there have been e-health and m-health applications for some time, the ubiquity of the mobile internet has allowed new applications. We're looking, for example, at the Siemens Minitech app, which connects hearing aids to phones and other devices using Bluetooth. Getting over the problem many people with hearing aids have, actually they are quite fiddly to use, and if your hands aren't quite as good as they used to be, difficult. And then also remote monitoring systems for long-term tracking of chronic diseases. Clearly, medical applications are one area where security and reliability are central aspects of user confidence. And by the way, an indication of the significance of digital health is there are over 300 exhibitors in the medtech space at CES. It's an increase of 40% on last year. I'm sure we'd all love to have 40% growth in our businesses. Of course, what would be ironic is the major beneficiaries of next generation mobility were not the young or the tech savvy, but actually the elderly and the sick. Interesting thought. Wearable technology, you see the graphic at the top left. Well, certainly an element of next generation mobility, based on the Internet of Things. The applications often sit in a space that encompasses both e-health and lifestyle or fashion choices. Another product you never knew you needed, the Colibri Smart Toothbrush, not toothpaste, not quite that clever, toothbrush unveiled at the show, provides data to your smartphone on your brushing skills, areas to focus on, and if you are a really controlling parent, you can track your kids' brushing habits. Nice to have, maybe. Some people may say that's a bit sad, but you might find it useful as well. In the end, of course, whether this is a technology or an application is another question. So, picture there of a vehicle with a battery with a socket coming out of it. Over the last few years, we've been seeing internet creeping into the infotainment applications in vehicles. So listening to an interview with Ford's CTO, it seems they've sold some 8 million cars with their sync application fitted. That's an application developed in conjunction with Microsoft. Of course, the reduced cost and increasing reliability of the mobile internet now means these applications can start to go to more critical uses. So, examples, for example, the e-call system in Europe calls the emergency services for you if you have an accident. I just hope this will reduce emergency response times by 40% in urban areas, 50% in rural areas. Quite significant if you happen to be the victim of a car crash. That time is likely to be the difference between life and death. Vehicle-to-vehicle applications as well. So, for example, you could identify the best route for you to take by your car talking to other cars and dynamically getting information on congestion, even before that information has been broadcast. And in both these examples, standardization of some sort is clearly essential if they're to work in a consistent and reliable manner. And progress in automotive area is now being helped by initiatives such as Qualcomm's new program, the Open Auto Alliance. But if we look at the Alliance's objectives, we see words such as accelerating innovation, making technology safer via the use of a common platform. Of course, common platform is often code term for standardization, but standardization driven by the platform provider. Disruptive technology is another example. Looking at the top, the rise of apps. So the graphic at the top is intended to show all the apps coming out or going into a mobile, into a smartphone. Explosion of the nature, a number of apps available across multiple platforms. It's also interesting to see the share prices of mobile phone companies with a hardware bias have underperformed those such as Apple with a mixture of hardware and software. Interesting point out that the market sometimes looks at these things and guesses and actually guesses where the technology is going. So what is the end effect of the increase in sophistication of software and the use of apps? Well, on the one hand, the use of apps is clearly a good thing. It's given a dramatic increase in consumer choice. However, as we well know, the quality of some apps is not always what it could be. I'm sure you've had experience of downloading things, you look at it and then you say, actually, this is a load of rubbish. Why did I bother? And of course, this quality can have significant security implications. This is not, for a lot of apps, this is a trivial issue, but it becomes much, much more important when we're talking about financial transactions or other personal information you would rather keep to yourself. However apps develop though, they are clearly a major component of next generation mobility. Another disruptive technology which you've seen at the show is 3D printing. I think no discussion of disruptive technology would be complete without a reference to it. As the technology comes down in price, devices such as the MakerBot's Replicator Mini, so it opens up new applications. However, it's interesting, it's not yet the killer app that will make us all want to rush out and spend $5,000 on a 3D printer. Certainly not me. There might be other people in this hall, but certainly not me. But, so whilst clearly not directly a mobile technology, printers are, by definition, quite large. I think it's likely to have an impact on the supply chain, and hence, indirectly, on next generation mobility. Now let's talk about a couple of the companies around disruptive technology and disruptive trends. So, whilst disruption is often associated with startups, it's also been interesting to see the increasing impact of larger organizations. And one significant trend has been the need for mobile phone giants to find new sources of revenue. So, as reported by many news sources, Samsung announced last week that their Q4 earnings would be 20% below expectations. And there was speculation that this was caused by price pressure on high-end smartphones. Whatever the cause though, I think we can be confident that Samsung management will use this as an opportunity to drive further change in the industry. They're not going to take this lying down. Another example, Sony. So commentators have observed that Sony is back as a real challenger in the mobile phone areas, having some people's view, marked time for the last few years. And it was really interesting to see Sony launch a number of new wearable products at CES to complement their mobile phone technology. When we look at the companies involved, we also have disruptive conflict between the old and the new. We have a wide range of companies, from new startups to established organizations such as Apple, Microsoft, Samsung. Of course, let's remember that the old here is actually not very old at all. For example, Apple, founded in 1976, not that long when you look at the manufacturers in other sectors. For example, the 9 major auto manufacturers that I mentioned earlier, substantially old organizations. And indeed, at the time Apple was founded, the former #1 mobile phone manufacturer, Nokia, now part of Microsoft, another established business, was still making tires. So, old is not that old. But of course, with the current ubiquity of mobile phone products, it's difficult to believe the first mobile phones did not start to arrive until 1978. Yes, there are people in this hall who can remember growing up without mobile phones. Scary but true. Of course, even in my own business, UL, we're seeing the effect of these disruptions. Incidentally, UL was founded in 1894, which makes us one of the longer established companies in this business. But I think our mission of making the world a safer place is as valid today as it ever was. But despite the fact our mission remains valid, we're seeing significant changes to our business as a result of these disruptive forces. One example is a reduction in consumer demand for traditional mains power products. Seen at CES very clearly, almost everything is DC, low voltage DC, or battery power. And this has led to a reduction in demand for plastic safety testing, which UL based its name. However, this has been more than counterbalanced by a huge increase in the need for other services. From wireless approvals, some of which directly involve safety, through interoperability, performance testing, to security and software validation, all directly or indirectly related to the mission of making the world a safer place. So, we have lots of disruptive forces, but of course, where there's a force in one direction, you sometimes get a force, there are often forces opposing it. If you look carefully, you can see the man is trying to cut the guitar strings in this graphic here. This can be a good thing. The forces against disruption can be a good thing because actually there is a need for consumer protection. There is a need for us to enforce safety. Great to have disruptive technology in your car if it causes the car to crash. Perhaps not such a good thing. But it can also be a bad thing because there are unscrupulous people out there set to exploit weaknesses in the technology. We exploit weaknesses for their own ends. So let's look at a couple of the forces that are acting against disruption, opposing the disruptive technology. First one is government regulators. An obvious force. Pressure for regulation is generally a positive thing. Pressure is generally a positive thing. And it is driven by concerns for safety and for the environment. So we see examples up here pertinent to smartphones and next generation mobility, including the FCC regulations to control the electromagnetic interference, reducing pollution of the radio spectrum, and the OSHA requirements for safety of mains power devices, otherwise known as the UL mark. I was very pleased that the box down here has a UL logo on the back. And of course, at this point, I should mention that other marks are available. As they say, all the best TV commercials. An interesting development in recent years has been the increased interest in the effect of radio transmissions on human health. And we see this in the USA with the extension of the FCC, Federal Communications Commission regulations, for intentional transmitters to include SAR requirements. For those who haven't come across this before, SAR stands for specific absorption of radiation and is a measure of the heating effect of radio waves on human tissue. In other words, is my mobile phone going to fly my brain? And the answer, in most cases, is fortunately no. Of course, in some markets, regulations are sometimes created for less noble reasons. Obvious examples being protectionism, seeking to reduce imports, and in some countries, for direct radio revenue generation by actually putting required fees that are levied on importers. So, also, while not strictly regulatory, another form of requirement relevant to smartphones is industry programs such as Bluetooth and Wi-Fi certification, as these are driven by the industry rather than they can be much more responsive to the needs of disruptive technology than government regulators can. Talked about governments, generally a positive force, generally responsive to the electorate in one way or another in a democratic system. We have another force a lot less responsive to people. Hackers, a much more insidious force, can disrupt the disruptors. Criminal activity quite often, criminal activity or, either done for commercial reasons or sometimes often just for the fun of it. Almost every bank now has a range of smartphone apps. Most people in this room probably use apps to do mobile banking. And mobile banking is one of the most obvious aspects of mobile commerce, otherwise known as m-commerce. Companies are often reluctant to reveal when they've been attacked, which makes it quite hard to track the level of activity. However, I was struck by a couple of announcements in December. And apologies, these have a slightly Eurocentric bias. First one, from the UK, the Royal Bank of Scotland, where a British newspaper reported hackers target RBS, crashed their online banking for an hour, inflicting the bank a second breakdown in a week. The bank was admitted it was targeted by attacking and took the unusual step of admitting that today's outage was caused by the hackers. Now, in this example, it's not clear whether there was a direct commercial motive. But very embarrassing, very expensive for the bank, and expensive and annoying for the users. Next example, closer to the mobile phone industry, Vodafone. Vodafone Germany announced cyber criminals have stolen key information. 2 million customers. A range of details about people, name, address, date of birth, etc. Bank account number, quite significant. Not some of the more really sensitive stuff, but must have got very close to that. And it's a significant pool of information for criminals to work on. Information which actually has value on the black market directly. And the Vodafone just stated, attack was only possible with high criminal energy, insider knowledge, and happened deep in the company's IT infrastructure. We're not talking about amateurs here, this is professional, organised activities. And I think it's interesting to ask ourselves, how many companies, products or services could survive an attack by somebody with that level of access? Interesting point to think about. Of course, both these attacks happened at the back end rather than attacking smartphones or mobiles themselves. Great, you think, so that's us safe. Well, I don't think you should attach any particular comfort to that, but it does show that we need to address security at the server level as well as on the phones if consumers are to have confidence in mobile transactions. Confidence and reliability are key themes you need to keep coming back to if next generation mobility is to become a reality. On a slightly tangential note, I love this photograph. The consumer drones that were exhibited at CS. Of course, it'll be interesting to see the impact of a coordinated hacker attack on a fleet, a squadron, a flock of consumer drones. But hopefully, the security will be in place before these products become widespread. Now I'd like to come on and talk about the smartphone as a universal convergence device. But what does that mean? Well, and how does it fit into the concept of the next generation mobility? A universal convergence device means different things to different people. But a phone is one thing most people always carry with them. Even people like my children, who only wear a watch as a fashion accessory, won't leave their phone behind. So are some examples of the universal convergence device in practice. So, remote control for home appliances. This example here shows a light bulb that you can control from your mobile phone. Another example is the ability to control your home audio system from your mobile phone, an app, simple but useful application that I use whenever I'm at home, which unfortunately actually is not very often these days. Mobile payments, classic application for the universal convergence device. People often think of this as being restricted to applications that use NFC, near-field communications, to replace a contactless chip and pin card, sometimes referred to as tap and go. But in reality, mobile payments goes much wider than this and includes technologies such as online wallets, mobile web payments using WAP, SMS-based transactions, etc. These technologies all have their respective advantages and disadvantages. There's currently no outright winner. However, it's clear mobile payment is here to stay in one form or another, and will be a major part of the next generation mobility, providing we can get standardization right and maintain user confidence. The one thing that will frighten people off is stories in the newspapers about people losing money being siphoned out of bank accounts, etc. Mobile ticketing. Well, why carry a paper ticket when you can simply use your phone? Most obvious applications of this currently airline tickets, boarding passes, etc. But we're also starting to see more applications in the mass transit environment, either using the QR code or on the phone or NFC. Of course, one of the challenges with mass transit is you've got a lot of people going through a gate very quickly, normally quite often irritable because it's first thing in the morning or they want to get home and the train's crowded. So the system has to be fast. You need response times in the hundreds of milliseconds so as to prevent lines building up at the gate. Other uses of NFC in the ubiquitous convergence device, well, as well as payments and ticketing, we see uses in smartphone, keyless automotive systems. Hotel key on your phone, send the app to your phone, activate it so you don't have to check in, go straight to the room. Smart posters, so you can actually go and pick up information off a poster. Loyalty points, so you don't go to different hotels or different cards and numbers to remember that, or when you're shopping. Ticketing systems for events, etc. Building security systems, so again, you can get in and out of the building, in and out of the conference. Stock control via e-tags, all sorts of applications. Standardization for many of these things is driven by organizations such as the NFC form. Other uses of the ubiquitous convergence device, mHealth, I mentioned earlier, really hitting the mainstream, mobile health. Functions ranging as from condition management, actually tracking how well you are, hospitals at home, getting people out of hospitals. I always say, I really hate hospitals, they're full of sick people. Get people out of hospital as quickly as you can, monitor them at home. Assisted living, helping the elderly stay at home for longer in a secure and safe manner. Remote diagnosis for people who are away. You don't have to go and see the doctor actually, the doctor can see you. And of course, technology brings a new meaning to the old phrase, the doctor will see you now. Yes, the doctor will see you now via your mobile phone and do at least an initial first pass diagnosis, perhaps much more quickly, much more efficiently than could be done when you were having to go to the surgery to see you. Location-aware apps, a really broad category, but isn't it great? Take a photograph on your phone, not only does it timestamp it, it works out where you are, your position, and the name of your location. Great, well, great if you want to say you're somewhere else, of course, but a really good and useful tool. And as we know from the last few days in Vegas, I'm sure people here have enjoyed some of the delights that Las Vegas has to offer, including the inclusion of GPS in smartphones has opened up a whole new range of application, from maps to restaurant recommendations to things which we don't want to talk about on a polite conference such as this. See, someone's been looking at the apps anyway. Let's now talk about security. I touched on it a little bit, the need for security. We see from the examples above, it's a significant area of development for next generation mobility. So use a smartphone for transactional activities, where you're sending critical information to and from another person or a server or another system. Examples we've had: mobile payments, e-ticketing, transfer of personal or health-related records. Now, once money and personal information involved, users, you, me, everybody else, rightly demand a much higher level of reliability and security. This poses whole new challenges to app developers. The app developer who has to plan to keep the app and the transaction secure, even if other parts of the system, such as the phone or the operating system or other apps, have been compromised. You're developing an app for a transaction, you have to assume, in the worst case, everything else has been taken over by someone who's trying to attack your app and your transaction. That's no easy task, especially given the brain power is clearly going into developing malware and the sophistication of the resultant attacks. So not amateurs out there that are looking to attack our apps and our transactions. So it's now time to look at transactions, be they financial or personal, in more detail. Talked a little bit about NFC, near-field communications. It's a very common method of making secure mobile financial transactions. So short-range wireless technology, similar to that used for RFID tags. Many smartphones now support, probably most now support NFC. However, the biggest challenge to mass adoption has been the lack of infrastructure. You need the retailer, the shop you're going to invest in an NFC-enabled reader for you to make the transaction. And until now, it's been actually quite difficult for retailers to see the financial benefit for them. But that's now starting to change with a wider use of contactless smart cards, recognizable by there's a contactless logo on the card, and we're seeing increased uses of this as well for transit applications, mass transit. One example, in the UK, all London buses now accept payment by contactless cards. Go on the bus, go on your contactless card, okay? As well as using better known, there's the Oyster payment system, which is a prepaid card. Basically, the London Transport is saying, we want to get out of the money business. We don't want to be handling money. We're very happy for the credit card finance organisations who specialise in doing that. We want to get everybody on to using ultimately contactless or NFC or mobile payments to make transactions. And of course, it's interesting to see that this example for London buses was only possible because the infrastructure on the buses was compatible with relevant industry standards. So actually quite fortunate. It's, you could argue it was a deliberate choice, or maybe it was just fortunate that they actually had gone down a route which used industry standards, so they were able to make this choice and actually move over to using standard contactless cards and ultimately NFC-enabled smartphones. Now, smart card standardization. So, what are the standardizations to make this happen in a secure and reliable manner? This next slide might scare you a bit. I apologise, it's not actually as clear as I'd hoped it would be. Don't worry, I'm not going to go through all of these boxes in detail. But the sector is linked closely to banking, so it's always been a target for organised crime. As a person who interviewed a bank robber said, why do you rob banks? That's because that's where the money is. Consequently, we've seen a high level of standardisation driven by the financial organisations, and in particular the credit and debit card networks. Visa, MasterCard, American Express, Discover, etc. Some time ago, 3 of the payments networks, Europay, MasterCard and Visa, got together to create an organisation by the name of EMVCo. Europay, by the way, has since been subsumed by MasterCard and other organisations such as Amex and Discover joined this organisation. EMVCo is a name, and EMV is a name you'll see coming up a lot in smart card transactions. Is responsible for global standards for the interoperation of IC, or otherwise chip cards, with point-of-sale terminals, the readers that you see in shops and restaurants, and with ATMs, cash point machines. So as to authenticate credit and debit card purchases. It actually takes you away using a magnetic stripe, using a signature, using a chip, either a chip and then a signature, or a chip and more securely a chip and a pin to make your transaction. So, as well as ensuring interoperability of the cards, there's been an increase in the emphasis on the security aspects. By definition, your credit card, the credit card issued by the bank, is in the hands of the end user. And that means that a person with malicious intent has effectively unlimited time to hack into it. And consequently, the security analysis of chip card is very extensive. It includes independent review of the hardware and the software, using all the information that's available to the designer of the product. So therefore, a lot more information would be available to the end user. Plus also extensive range of fault injection, injecting faults to destabilize a microprocessor, see if you can get it to actually go into an error case and actually reveal information inside. And some of this analysis techniques includes use of things like lasers to strip away parts of the chip and inject signals deep within the architecture of the processor. Very, very sophisticated in order to be able to simulate in a short period of time what a hacker might be able to do if they spent months into. As a result, actually, smart cards, chip and pin cards, are actually pretty secure. A modern chip and design chip and pin card is a really secure device. So, the problem then is that's no longer the weakest link in the network. And it's important to remember that the criminal will go after the weakest link in the system. Why spend huge amounts of time attacking a hardened smart card when you go tap into the communications flow in the point-of-sale terminal or the communication to the back-end network? And this is what led to the creation of an organisation, another acronym, PCI, Payments Consumer Card Industry Security Standards Council, which complements the work of the IEEE. Of course, an interesting knock-on effect of the increased security of smart cards and transactions is that fraud has moved onto other platforms. e.g. onto online banking. Or very, very simple, low-tech fraud. Somebody watches you entering your PIN number, and as you go out of the shop, they steal your card from you. You've got the card and the PIN. And this is always important when looking at security analysis, going through, looking at your apps and how they work, actually always coming back to say, absolute security is not possible. What you need to always be doing is looking at how you improve the security of the weakest element in your network, the weakest element in your system. And you need that element to be secure enough, whatever secure enough may be for your application. But bearing in mind, you will never get absolute security. So talk about smart cards, and you may say, well, okay, fine, when's he coming back to smartphones? What happens when you transfer this concept, this mobile payment, this concept of smart card, onto a smartphone? So, well, we've seen in the banking world there's great emphasis on the security of the physical system. The payments terminal, the card with the embedded chip, the ATM, etc. So, the banking system actually, by applying standards, owns that hardware effectively. It owns the design of the hardware and the authorization to use it. Because payments migrate to platforms owned by the consumer, who own the smartphone. Banking services sector no longer has that direct control anymore over the physical security. So there has to rely increasingly on the software security rather than the hardware countermeasures. It's been a really difficult challenge for banks to get their heads around. So the net effect is that whilst the hardware smart card is or should be inherently secure, the same can't be said about the average smartphone, which is by definition an insecure device. There are many, many ways to get into it, hack into the operating system, jailbreak the operating system, people do all sorts of things. So let's look at the mobile payments ecosystem. Again, I'm not going to go through these slides, but just show a number of different players in this. What was a relatively simple ecosystem, you had the bank, you had the credit card company, 2 or 3 players, now we have 9, 10, 11, 12 players. Lots of players involved in the transaction. And in particular, we now have a major additional force. The mobile phone network operators may have a strong vested interest in this as well. Raises the question, who owns the service? The bank, the mobile network operator, handset vendor, the manufacturer, Google, the independent app developer, etc. So not only do we need standards to agree on agreement to be made, but of course for the system to be a success, there needs to be a clear route for people to make money out of it. And this was the logic behind the ISIS mobile payment system we use in the US, which brings together 3 of the mobile networks, a number of banks, credit card issues, etc. How do you imagine to manage security in this environment? Well, obvious answer is to develop a secure software kernel. It's known as a secure element. The secure element needs to remain secure, even if, as I mentioned before, the hardware or the OS on the phone are compromised. Payment application needs to have access to a secure element, and the secure element can be in the SIM, or in the smartphone itself, or in the recent proposed update to the Google Wallet, actually in the application itself. Always you need to have somewhere in the system that secure element. And of course, Google Wallet is particularly interesting because once again we see Google attempting to lead standardization, but obviously with the emphasis on Google software. Clearly they're not a charity. If they're going to lead standardization, they want you to standardize around their software. Thank you very much. And good luck to them. Of course, NFC is not the only game in town. Pick out another interesting alternative technology. Natural Security Alliance, based in France, aims to use biometric technology to verify payments. Just use your fingerprint. Whilst the additional products use Zigbee as a communication protocol, it's actually possible to make this technology agnostic. That's quite useful because you have different options: Bluetooth, low energy, Wi-Fi, Zigbee, etc. A number of different options in this. And in the long term, this may prove to be a more versatile option than NFC. And of course, the use of biometrics could remove some of the challenges with the theft of the smartphone or your smart card, because you need that biometric to complete the transaction. I think one of the key themes in this succession behind the success of electronic standards for payments is the number of independent organisations involved in developing the standards. But of course it's also interesting that most of these are backed up by one or more organisations acting as quasi-regulators. We can hear of the credit card networks, Visa, MasterCard, with direct financial interest in making sure transactions work and are secure. You want to make sure that you have a good experience, so you stop using cash and use their cards, and they certainly want to make the system secure, because first of all they lose money if it's insecure, secondly they lose user confidence. I'd like very quickly in the last few minutes to just look at some industry standardization programs. First of all, those relating to a smartphone. Well, one very nice one that's coming out at the moment is Wi-Fi, wireless charging. Having to carry charged around with you is a real nuisance. When they're just communications devices, smartphones, running out of power, it's not the end of the world. Now, actually, it's really a problem. So wouldn't it be nice to go to your favourite coffee shop, put your phone down on the counter, and it charges automatically? A really insignificant development potential. But of course, this requires sophisticated electronics for the protocol to allow the phone to talk to a charge station on the table. It costs money, and the head of customer experience for a coffee shop, and yes, those positions do exist in the major chains. They do actually have heads of customer experience. This person will really want to know that most, if not all, smartphones will work with the wireless charges that they specify. Clearly, a good example of where standardization can help innovation. So responding to this call, to the rescue comes the Wireless Power Consortium with their Qi standards, well, QI. And I quote from the Qi website, the idea behind Qi is simple. All devices with a Qi logo will work with all Qi charges. That's it. That's it indeed, and would be if there were just one standard in this area. But as many of you know, that's not the case. In fact, we currently have 3 competing standards for low-power wireless charging, namely the Power Matters Alliance, the Wireless Power Consortium, and the Alliance for Wireless Power. So I think this shows one of the problems of standardization in rapidly developing technologies, the proliferation of competing standards. And while this can be positive for innovation in the short term, adds complexity to manufacturers. But fortunately in this situation, Qualcomm have now joined all 3 of the consortia, which should hope cause the standards to converge. But obviously, as with Google in the previous examples, Qualcomm will be hoping that they converge on Qualcomm technology. But standardization is clearly essential to give confidence to shops, etc., to invest in infrastructure. Another example got up there, conflict minerals, something many people would consider, but actually is important in the, because a lot of the minerals going into products, some of them come from this desirable areas. And it was interesting that Intel last week announced that the pledge to eliminate all conflict minerals in their products. It'll be interesting to see how this spurs standardization, both driven by regulators, but also by industry bodies in this area. And the final one I'll come on to briefly, wireless infrastructure. All of this behind our universal convergence device actually is underpinned because we rely on the fact that things work. They do communicate. I'm not going to go into the details of this. The most obvious consortia being people like things like Wi-Fi Alliance, Bluetooth, and the GCF and PTCRB requirements for cellular mobile communications. You go out today into a shop on the strip, buy yourself a new mobile phone, get on a plane to Brussels, Beirut, Beijing, get off, and your phone will work. That happens because of a huge amount of effort that's gone in over the years by industry, by network operators, by manufacturers of products, by test labs, etc., into making this happen. And these organisations have got together and actually developed these standards despite their often divergent interests. So, very quickly, just to think about how do we make standardization more agile? Because things are getting more disruptive, things are moving faster. We can all run faster, we can all try and have more meetings, more online meetings, etc. And I think it's a good time for us to look at this, because actually running faster isn't a solution in the end, I think. And we may need to actually look at radical alternatives. Should we be looking at crowdsourcing for standards writing? Should we be looking at building on the work of Wikipedia or the open source software movement and things like this? Some interesting ideas which perhaps are worthy of discussion on another day. We've also seen, of course, that much of the standardization has been driven at the moment by large companies, Google, Qualcomm, Visa, MasterCard, who have direct reasons for encouraging standardization, providing it's built around their technology or infrastructure. And in some ways it's really good for the consumer, but it can become a problem. Where one company's technology or system becomes so prevalent that drives out competition, ultimately stifles innovation. And clearly it's an area where independent standards become more significant and maybe a further driver for more agile routes to standards development in the future. So, really just to conclude, seen a number of examples where standardization applies to innovative technologies. Customer confidence is critical if innovation is to translate into commercial success. And it was seen that standardization is an important component in developing user confidence in new technology. But the process needs to be able to respond very quickly, not only to develop new standards for new type products, but also to rectify flaws that come to light on standards of use. Overall, in answer to the question at the start, my verdict is that appropriate standardization is an important enabler for the commercial success of innovation. And as I said at the start, we certainly live in interesting times, but hopefully in a positive way. Thank you.